So today we are going to discuss JEE main September 5 paper, that is shift 1. See the first question. 3 different processes that can occur in an ideal monoatomic gas are shown in the figure. The paths are labeled as A to B, A to C, A to D. The change in internal energy during these processes are taken as EAB, EAC and EAD, and the work done as WAB, WAC and EAD. Which of the following is correct relation? So, see that diagram. So, in the diagram, the internal energy U is equal to what we write here, F by 2 N naught dt, F by 2 N naught dt. So, if we consider from A to B, the temperature difference is T2 minus T1 or T1 minus T2 from A to B. From A to B, the temperature difference is T1 minus T2. A to C, from A to C, the temperature difference is also T1 minus T2. From A to D, the temperature difference is T1 minus T2. Here the temperature difference is same. Internal energy depends upon only initial and final temperatures, does not depend upon path followed. So, we conclude that EAB is equal to A to B is equal to F by 2 N naught T1 minus T2, and also here EAC is equal to F by 2 N naught T1 minus T2, and also EAD F by 2 N naught T1 minus T2. So, here EAB is equal to EAC is equal to EAD. So, here energy is same, internal energy is same. Why? Because here temperature difference is same, temperature difference is same. F does not change, N does not change, R does not change. Okay, right. Now, we calculate the work done between A to B. From A to B, see the diagram, pressure is constant, pressure constant, but volume is increasing, volume is increasing. Okay. So, here that means WAB is greater than 0, WAB is greater than 0, WAB is greater than 0. So, WAC, now we calculate AC. See that AC, A to C, which is constant, volume is constant, From graph we observe that volume is constant, pressure increases. So, WAC is equal to, here we write P into dV, that is equal to P into, there is no change in volume, So, here we write 0, that is equal to WAB is equal to 0. Okay. Now we calculate WAD. See the diagram. In that AD here, when we go A to D, volume is decreases. So WAD is less than 0. W is less than 0. Volume decreases here. Volume is decreases. So our correct option is fourth option. But notice that in that fourth option, WAD is greater than 0. So that is given as wrong. So our option is WAD less than 0. Why? Because volume is decreases. So next question is, when increasing bias voltage of a photodiode, the photocurrent magnitude is. So this is photodiode. So what is meant by photodiode? The diode which converts light energy into electric energy, that is called photodiode. Whenever here the light with a certain intensity is incident on the photodiode, then what happens? Electron hole pair is generated. So these electron hole pairs are separated. Okay, these electron hole pairs are separated. The electrons are separated and the current is produced. Now when we connect a battery to the photodiode, then what happens? When we increase biasing voltage, then more current is produced. So if we draw the graph for different intensity of light incident on photodiode, then the graph looks like this. That means what? Here the photoelectric current increases gradually and it saturates. So when we increasing biasing voltage, what happens? It increases, photoelectric current is increases and initially and saturate finally. So that is our option. Okay, right. So let us discuss third problem here. What is the third problem? A square loop of side 2A and carrying current I is kept in xz plane with its center at origin. A long wire carrying the same current I is placed parallel to the z-axis and passing through the point 0 B 0. B is greater than A. The magnitude of the torque on the loop about z-axis is given by. So here there is a square loop. Okay, this is a square loop of side how much? 2A. Of side how much? And the center of the square is coincide with this origin. let us this is square loop is kept in xz plane, plane, which is kept in xz plane. Okay, the square loop is kept in xz plane. And also there is a long wire carrying a same current I is placed parallel to the z axis, parallel to the z axis, parallel to the z axis, and which is located at B. So, located at B distance from the origin, B distance from the origin, located B distance from the origin, right. Now, what is the side length of the square loop here? 2a. Side length of the square loop is 2a. What they ask? The magnitude of torque on the loop. So, whenever the current I is passing through this conductor, then what happens? Magnetic field is developed. So, in that magnetic field, the square loop is kept. So that whenever the square loop is kept in the magnetic field, then what happens? It experiences a torque. The current passing through the square loop is also I. So, now we want to calculate the torque. Torque is equal to formula what? mb sin theta. Torque is equal to mb sin theta. So, torque is equal to m. M means NIAB. N means how many number of turns here in this loop? Only one turn. So, I AB. AB. A means area. NIA. A means area. Area is nothing but 4a square. B. Theta value is 90 degrees. Sin 90. Theta is the angle between M and B. M and B. So, here the current is passing through this long conductor is along this direction, along this direction. That means here, so the magnetic field is along this direction, the magnetic field is along this direction, and the loop is in xz plane, the loop is in xz plane. The area vector is vertically upward, vertically upward. So, the angle between area vector, that means magnetic moment vector, and magnetic field is 90. So, tau is equal, we get what here, I into 4a square B. According to Ampere law, what we write? We law mu naught I by 2 pi r, mu naught I by 2 pi b, 2 pi b. So, torque is equal, we write here 4a square, that is equal, here 2 gets cancelled 2 times, 2 I square mu naught a square divided by pi b. So, what is our correct option? The correct option is option 1, pi b, option 3, 2 mu naught I square a square by pi b. This is correct option. So, here the square loop is in xz plane. That means whenever we want to find out magnetic moment, it is along parallel to the area vector, that is vertical upward direction. But the current passing through this straight conductor is along this direction. So, this is magnetic field produced is along this direction. Okay. This magnetic field and magnetic moment are perpendicular to each other. So that angle is nothing but what? 90 degrees, theta is equal to 90. So finally we got to answer this. So now let us discuss question number 4. So what is that question number 4? Here assume that the displacement of air is proportional to pressure difference delta P created by a sound wave. Displacement S further depends upon the speed of sound V and density of air rho and the frequency of. So if delta P is equal to 10 pascals, V is equal to 300 meter per second, rho is equal to 1 kilogram per meter cube and F is equal to 1000 H, then S will be in the order of. So we know that whenever a sound wave is propagated into air, the pressure is created in a medium. Due to this pressure, the particles of the medium gets displaced. So here delta displacement is directly proportional to pressure difference. Displacement is directly proportional to pressure difference. Right. So that means delta P, we know that pressure amplitude delta P is equal to SBK. SBK. So S is equal to delta P divided by BK. But B is equal to, we know that velocity of sound in a medium B equal to B by rho, bulk modulus by density. So here V square is equal to B by rho. B is equal to V square into rho. V square into rho. And we know that omega by K is equal to V. Omega by K is equal to what? Here V. Now K is equal to omega by V. Omega by V. Substitute these values in this equation. So S is equal to delta P divided by B means V square rho into K omega by V. That is equal to delta P into V by V square into rho into omega. Okay. So S is equal to pressure amplitude. So delta P is equal to how much? 10. And the velocity, what they given in the problem, 300 meter per second, divided by V square 300 into 300 into rho, they given density 1 kilogram per meter cube, 1 into omega 2 pi F. F means frequency. What they given frequency? They given frequency 1000 Hz. 1000 Hz. So here we write here 300 cancel, 300 cancel, and 0 cancel. Okay. Now we get here 2 pi into 1000. So here 1 by, what we write here, 1 by, so 30 into here 2 pi is a constant, 2 pi is nothing but what? Constant. So we write here 10 cube. meters. So, here S is equal to, we write, so 1 meter is equal to how many millimeters? Answer is given millimeters, 1000 millimeters divided by 30 into 10 cube. 30 into 10 to how much? 10 cube. That is equal 1 by 30. That is equal what we write here 1 by 30. We write this 1 by 30 as 3 by 90. That is almost are equal to 3 by 100 millimeters. So, our correct option is option 4, 3 by 100 millimeters. So, let us discuss another question. That question is asked from electrostatics. Two capacitors of capacitance C and 2C are charged to potential difference V and 2V. These are then connected in parallel such that the positive terminal of one is connected to negative terminal of other. The final energy of the system is. So, these are the two capacitors. So, this is one capacitor and this is another capacitor. It is charged to potential V and it is charged to potential 2V. So, they connected such that negative terminal of the first capacitor is connected to positive terminal of the second capacitor. Okay, like that they are connected. Right. Now, what is the final energy of the system? So, in this question, charge is conserved. Initial charge is equal to, here this is charged to potential, this is charged to potential V and this is also charged to potential 2V. So, initial charge, here this negative plate on the negative charge on the negative plate is minus CV plus here 2C into 2V. Positive plate, charge on the positive plate is 4 CV is equal to final charge. Whenever they are connected parallel, they attain common potential. Final charge is common potential V dash into total capacity C plus 2C. They are connected in parallel. They are connected in parallel. That's why we write C plus 2C. Right. So, here 3CV is equal to 3CV dash. So, V dash is equal to V. V dash is equal to V, final potential. Now, we calculate potential energy, final potential energy. Final potential energy. Final potential energy of a system. U is equal to final charge Q square by 2C, final capacity. This is the fifth problem. So, Q square final Q is equal to CV dash, final charge 3CV whole square divided by 2C. That is equal to what we write here. That is equal to, here we write here final capacity is 3C, 9C square V square divided by 3C. 3 cancel. Finally, we got here 3CV square. 3CV square. 3CV square. here. Here also there is 2 is also in the denominator, 2 into 3c, 3cv square by 2. So, final answer is 3cv square by 2. Here 2c, c is nothing but final capacity. Final capacity when they are connected in parallel is 3c. So, 2 into 3c, that is equal to how much here? 3 by 2 cv square. 3 by 2 cv square. So, this is the answer. So, among the following, what is the correct option? Here correct option is option 4. Option 4. So, now let us discuss another problem. A helicopter rises from rest on the ground vertically upwards with a constant acceleration g. A food packet is dropped from the helicopter when it is at a height h. So, the time taken by the packet to reach the ground is, which of the option is following? So, the helicopter is rages from point A and reaches to, suppose, point B, up to point B, and reaches to height h. So, after reaching the point B, it drops a body. So, that body raises up for certain height and reaches to ground, after time t seconds. So, now we want to find out what the time taken by the body to reach the ground. So, here first of all we calculate what is the height reached by that helicopter, that is h, and with what velocity the stone reaches to this ground, that is we are going to find out. Okay. Now, here we know that v square minus u square is equal to minus 2gh, So, here v a square minus u means we assume as v b square is equal to minus 2gh. The helicopter is starting from rest. That means this initial velocity is 0 minus v b square is equal to minus 2gh. So, v b square is equal to 2gh. v b is equal to square root of 2gh. With this velocity, the food packet is dropped from that point, from this point. Here the velocity v b is equal to how much? Square root of 2gh. Okay. Now, we have one formula, that is h is equal to projection of a body from the top of the tower minus ut plus half gt square. This is the formula. So, h means how much here? Half gt square. Half gt square is equal to minus u, with what velocity it reaches to the ground? Minus 2gh into t plus half gt square, right. So, here we retained h as h. Now, doing cross multiplication, what we get here? 2h is equal to minus 2 root 2gh t plus gt square. Now gt square minus 2 root 2gh minus 2h is equal to 0. Minus 2gh is equal to 2h is equal to 0. So we use to find out t, we use the formula minus b plus or minus square root of b square minus 4ac. B square minus b, that is equal to 2 root 2gh plus or minus b square minus that means here 8gh b square minus 4ac, that is equal to 8gh by 2a, that is equal to 2g. Right. Here this is the value of t. T is equal to, now we write here 2 root 2gh plus or minus square root of 16gh by 2g. So t is equal to, split the bracket here, 2 root 2g h by 2g plus or minus here take 16 outside. So we get here, whenever 16 comes outside, 4 gh by 2g. Now t is equal to 2 gets cancelled here. This is we get square root of 2h by g plus or minus 2 root h by g, okay. So here t is equal to root h by g is root h by g is taken as common, Now what we get here, root h by t taken as common means root h by g, that is equal to root 2. We take plus value only. Why? Because here the time is always positive, plus 2. So t is equal to, we get square root of h by g, 2 plus 1.414. T is equal to square root of h by g, 3.14. Here 3.4, sorry, 3.4. So finally we get option 1. Option 1 is correct option. Okay. So this is a model of projection of a body from certain height. Right. So next problem we are going to discuss about a bullet of mass 5 grams traveling with a speed 210 meter per second strikes a fixed wooden target. One half of its kinetic energy is converted into heat in the bullet, while the other half is converted into heat in the wood. The raise of the temperature of the bullet if the specific heat of its material is. Right. Here this is a bullet. This bullet is strikes this wooden block. Bullet mass is equal how much? 5 grams. And with what velocity it strikes? It strikes with 210 meter per second. Right. Here S is equal to what they given, S is equal to 0.03 calorie per gram centigrade. 0.03. Specific heat of material is. Specific heat of material is. So, this should be converted into SI system. S is equal to 0.03, 1 calorie is equal to 4.2 joules divided by 10 to the power of minus 3 joule per kg centigrade. Now, here how much kinetic energy lost by the bullet here? This is a bullet and this is block. This bullet comes out with half of its kinetic energy. Initial kinetic energy is half mv square. The final kinetic energy is half of its initial kinetic energy, half of its mv square. Remaining half is converted into heat in the block. So, half of mv square is equal to ms delta T. Okay. Due to that heat, the temperature of the block is increases. The temperature of the block is increases. Now, 1 by 4 V square is equal to S into delta T. S into delta T. Here, we want to find out what here? We want to find out rise in temperature of the block. Delta T is equal to V square by 4S. V square by 4S. So, V square by 4S. Right. Now, here we are going to solve the calculation. V square is equal to 210 into 210 divided by 4 into S value is equal to how much? 0.03 into 4.2 divided by 10 to the power of minus 3. 10 to the power of minus 3. 10 to the power of minus 3. Now, delta T is equal to, here we write 210 into 10, that is equal to here 441 into 441 into 10 to the power of 2. Okay. Into 10 to the power of minus 3, 10 to the power of minus 3 divided by here 4 into 3 into 10 to the power of minus 2 into 4.2. 4.2. So, what we get here delta T is equal to 441 into 10 to the power of 4 into 10 to the power of minus 3 divided by 4 3 is 12, 12 into 4.2. So, 12 into 4.2, what we get? Let us calculate the 12 into 4.2, that is 50.4. 50.4. So, we get here delta T is equal to 441 by 50.4 into 10. That is equal to, we get here 87.5 degrees centigrade. So, this is our answer. So, our option is option 2. So, next problem we are going to discuss from rotatory motion. A wheel is rotating freely with an angular speed omega on a shaft. The moment of inertia of the wheel is I and the moment of inertia of the shaft is negligible. Another wheel of moment of inertia 3I initially at rest is suddenly coupled to the same shaft. The resultant fraction of loss in the kinetic energy of the system is. So, this is a wheel which is rotating with a speed omega. Okay. And another wheel of moment of inertia which is at rest, omega is equal to 0, which is whose moment of inertia is 3I. Okay, initially it is second wheel is rest. So what happens after some time, these two shafts are coupled. Two shafts are coupled and they rotate with common angular speed omega f. Due to that, what is the fraction of kinetic energy lost in the system? So we use here law of conservation of angular momentum. I1 omega 1 plus I2 omega 2 is equal to I1 plus I2 into omega final. I1 means here I into omega plus this second shaft is at rest 0, that is equal I1 plus I2 4I into omega final. So omega final is equal to, here we got omega by 4. This is equation 1. Loss in kinetic energy of the system is, so now initial kinetic energy, K initial kinetic energy is equal to, initially the first shaft is rotating with the angular speed omega, second shaft is second wheel is at rest. So we write half I into omega square. So K final is equal to half. After they combine, the total moment of inertia is 4I into omega square, omega final square is equal to omega by 4 whole square. So here Ke final is equal to half I omega square by 16 into 4, by 16 into 4. So Ke final is equal to, here initial kinetic energy Ke by 4, okay, half I omega square, that is initial kinetic energy. 4 is cancelled in 16 4 times. Next, fraction of loss in kinetic energy is equal to initial kinetic energy minus final kinetic energy, Ke initial kinetic energy minus final kinetic energy Ke by 4 divided by initial kinetic energy. Okay, this is we get here 3 Ke by 4 Ke, that is equal to how much fraction? 3 by 4. So our correct option is how much? The correct option is 3 by 4, option 1. Option 1. A balloon is moving up in air vertically above a point on the ground. When it is at a height h1, a girl standing at a distance d from A sees it at an angle 45 degrees with respect to the vertical. When the balloon climbs up further height h2, it is seen at an angle 60 degrees with respect to the vertical. If the girl moves further by distance 2.464 d, then the height h2 is given as, is equal to how much? That is we are going to discuss. So here this is a balloon. This balloon is raises to a height h1. At this point the balloon is seen by a girl. A girl is located at a distance d. The girl is seen that balloon with an angle 45 degrees with vertical. Now the balloon is raised further to a height h2, and the girl is walking further distance 2.464 from point B, this is A, and reaches to C. She saws that balloon from point C, with an angle 60 degrees with the vertical. Now we want to find out what is the further height raised by the balloon, h2. So we solve this problem by using a trigonometry relationship. Here this angle is 45 and this angle is 30. So now we are going to discuss tan 45 is equal to, here height is equal to how much, h1 by d. So tan 45 is equal to 1, that is equal to h1 by d, h1 is equal to d. Equation how much, that is 1. Now in the case 2, tan 30 is equal to opposite side h1 plus h2 by hypotenuse. What is hypotenuse here? Opposite side by adjacent side, d plus 2.464 d, plus 2.464 d. Right. Here this is equation 2. Now tan 30 is equal to how much? 1 by root 3 is equal to h1 plus h2 by d plus 2.464 d. Now doing cross multiplication, root 3 into h1 plus h2 is equal to, here 3. What we get here, 464 d. So here root 3 into h1 is d plus root 3 h2. So here h2 only, h2 is equal to 3.464 d. Now multiply this into root 3 d plus root 3 h2 is equal to 3.464 d. Root 3 h2 is equal to 3.464 d minus root 3 d. So root 3 h2 is equal to, what we write here, d into 3.464 minus 1.732. So h2 is equal to, here what we write here, root 3 h2 is equal to d into, this is 1.732. So here root 3 is also 1.732 into h2, that is equal to d into 1.732. This is cancelled, h2 is equal to, we get d. So in this problem our option is the option 2, d. So next problem is, an electric power line having total resistance 2 ohms delivers 1 kilowatt at 220 volts. The efficiency of the transmission of the line is approximately. So this is a electric power line whose resistance is how much? 2 ohms. It delivers power is equal to, output power is equal to 1 kilowatt. Okay. The efficiency of the transmission line is, so neta is equal to, we do not output power by input. So neta is equal to P out divided by, so there is some energy loss in the output power, So P out plus there is a loss of energy. Whenever the current is passing through a wire of certain distance, some energy is lost in the form of heat. Now how much lost here? P loss is equal to I square R, that is equal to P by V whole square into R. P means how much? 1000 watts by V 220 into resistance 2. So P loss is equal to we get here after doing calculation, this is whole square, 0 cancel, 511 here 250s 211s, so 2500 by 121 into 2. So I did this calculation on rough notes, so I will give you value to 20.66 into 2, that is equal 41.32 watts. This is the loss. Now here we substitute this value. Neta is equal to P out is equal to 1000 divided by 1000 plus 41.32. Okay, this is total input power, but output power is equal to how much? Only 1000. That means loss is equal to how much? 41.32. Right, neta is equal to, we get here 1000 by 1041.32. So neta is equal to, we get here 0.96, that is equal to 96%. Efficiency of this transmission line is 96%, that is option 4. Activities of 3 radioactive substances A, B, C are represented by the curves A, B, C in figure. Then their half-lives are in the ratio. We know that activity R equal to R naught into e to the power of minus lambda t. So take logarithm, ln R is equal to ln R naught plus ln e power minus lambda t. So ln R is equal to ln R naught minus lambda t ln e. So ln R is equal to ln R naught minus lambda t. Ln e value is 1. So here ln R is equal to minus lambda t plus ln R naught. So this equation is similar to y is equal to mx plus c. So here this is m is slope m is equal to here lambda. Okay, m is equal to lambda. We know that half life is equal to T off is equal to 0.693 by lambda. So here we take the slope of each line, lambda A is equal to 6 by 10, that is equal to 0.6. Lambda B is equal to, what we take here, lambda B is equal to 4 by 5, and lambda C is equal to, here 2 by 5. Now we start here. Now, so T A is to T B is to T C is equal to 0.693 by lambda A, 6 by 10 is to T B. T B means here 0.693 by lambda b 4 by 5, 0.693 by lambda c 2 by 5. So, here T A is to T B is to T C is equal to 10 by 6 is to 5 by 4 is to 5 by 2. 5 by 2. Now, here we write LCM as same. So, for B we write here, slope 6 by 5, 6 by 5. So, please correct 6 by 5. So, here also this is 6 by 5, that is equal to what we write here, that is equal to 5 by 6 here, 5 by 6 is to 5 by 2. So, we must equal the LCM. For that 10 by 6 is to 5 by 6 is to, this can be written as 15 by 6, 15 by 6. So, T A is to T B is to T C is equal to 10 is to 5 is to 15, that is equal to 2 is to 1 is to 3. So, what is our option is, in the given values our option is fourth option, option 4. So, here accidentally we write we make a mistake in the determination of slope of B line. Lambda b is equal to here, lambda b is equal to, see the diagram. So, this is the B line, this is 6 by 5, 6 by 5. Okay. Please notice that. So, our option is 2 is to 1 is to 3, 2 is to 1 is to 3.